be very welcome. The International Movement for Leisure Activities in Science and Technology MILSET is very excited to present the MILSET World Virtual Young Citizens Conferences 2020. The aim of this program is to hear the concerns, opinions, and proposals of young people from all over the world regarding science and technology issues that affect humanity. This year, we have been confined by a super contagious virus, but we haven't been silenced. So, MILSET presents this conference cycle to give the latest information from top speakers and to think how to invent a new world. My name is Liz Vela, MILSET Communication Manager, and I wish you enjoy this lecture. We will be streaming live on MILSET Facebook, MILSET AMLAT Facebook, and MILSET YouTube channel. I want to thank MILSET Executive Committee, MILSET Regional Executive Committees, MILSET Honorary President, MILSET YCC Committee, MILSET members, and all the audience that are watching this broadcast. At the end of the conference, there will be a space for an answer and question section. So we suggest to write your questions on the corresponding channel. Now, I give the floor to MILSET President, Mr. Roberto Hidalgo. Mr. President, the mic is yours.
Thank you very much. It's an honor to be in that virtual transmission to all over the world. So good morning in some countries, good afternoon in other ones, and good night in the rest of the world. We are very proud to present our MILSET Young Citizens Conferences that are a program. This is a program dedicated to the views and concerns of youth, mainly regarding social impact on science and technology and innovation. We are trying to invent a new world. So your voices from all over the world, from all the youth, will be compiled in only one voice. And this voice will be encouraging to make you participating actively in these discussions. So we have many surprises and many great friends participating in that program. We are starting our YCC, or Young Citizens Conferences, this year with a spectacular conference, and I would like that everybody can enjoy. Do not forget to visit our MILSET website, milset.org, and you will find a lot of activities for you, as our science photo contest, as our MILSET Expo Sciences, and of course, all the participation about the MILSET Young Citizens Conferences. So now I would like to introduce Mrs. Bere Suarez. She is our MILSET director, and she will introduce our lecture for today. So please, Bere, welcome, and the word is you.
Thank you, Mr. President. It's an honor for me to be here, and I'm so happy to be part of this activity. Well, I am also honored to introduce a great visionary who has been leading the promotion in science and technology for youth in many years ago, Mr. Eugenio Urrutia Vice-Rector. He has an extensive academic training with a bachelor degree in chemical engineering, a master of business administration, both degrees from UPAEP University in Mexico, a master of science in food technology from the CSIC in Valencia, Spain, as well as a science and technology education certificate from the Mashup Center in Jerusalem, Israel. Also, he is founder, director of the Center of Studies in Science and Religion, CECIR UPAEP, and he has been 3 times grand winner of the editions of the Metanexus Global Network Initiative by the Metanexus Institute on Science and Religion in Philadelphia, USA. He chaired the Latin American region of the International Movement of Leisure Activities in Science and Technology, MILSET, and currently he is appointed as a special consultant for the MILSET Executive Committee. He also has participated in the production of the book titled Science and Religion, Dialogues Around Nature in 2002, and in the translation to Spanish of the books Physics, Philosophy, and Theology in 2002, Bridge Between Science and Religion in 2004. Currently, he has been appointed as a Vice-Rector for Research by UPAEP, and today, Mr. Eugenio Urrutia will share with us his amazing experience as a General Director of the project Aztechsat-1, that is the first Mexican nanosatellite that was deployed from the International Space Station the last January. Welcome again, Mr. Eugenio, to this MILSET World Virtual YCC Cycle of Conference.
Mi visión desde el comienzo fue de que la misión, el proyecto Aztechsat-1, fuera 100% mexicano. Desde los requerimientos, el diseño, la construcción, todo fuera trabajo de mexicanos.
Este nanosatélite va a ser el primero hecho en México y va a estar en órbita, lanzado por la NASA, y no ha habido otro caso similar en la historia del país.
Ya no hay vuelta atrás, ya la fecha está establecida, tenemos que poner todos nuestros esfuerzos en marcha y vamos con todo. La verdad estamos muy motivados en todos los equipos y con las miras puestas en la fecha final.
Más que ser individuales o querer dividir en cuanto a instituciones, somos todos México, porque estamos haciendo historia en este país, estamos haciendo algo hoy por el México del mañana.
Ignition sequence start. 6, 5, 4, 3, 2, 1, 0.
Hi, everybody. First of all, I would like to thank MILSET for inviting me to give this talk. I am very honored to do it, and I would like to wish you a very, very good morning, a very good afternoon, or a very good evening. Thank you very much for joining us. And first of all, I would like to show you what I am going to talk. Number 2, please. Number 2 slide. Okay, sorry. This is a CubeSat. This is the kind of satellite we sent to the space. It's a very small satellite, only 10 times 10 times 10 centimeters each side. And this is only almost 1 kilogram as weight of it. As you can see, this is not huge satellite, but it has a very, very powerful characteristics to develop its mission. And I'm going to talk about the mission. The mission we had, NASA gave us this mission number 3 to demonstrate that it is possible to have communication between a small satellite, a nanosatellite, and a constellation of satellites, commercial satellites called Global Star. This is very important because if this is possible, and it is, it is going to be cheaper to send information from the space to the Earth, to ground stations in Earth, about the information that the nanosatellite is receiving. Now they have to send the information to a ground station, so we need a lot of ground stations on the Earth in order to get down the information. But with this system, it will be only necessary to send the information to these commercial satellites, and then they send the information to the Earth. And so this is a very, very economical way to resolve a huge problem. So the mission was to send a satellite to the space through the International Space Station, and then the satellite was deployed, and after 1 hour, our satellite was sending information to the global star constellation and also to Earth. So we can say in advance that the project was a successful project. Next, please. Number 4. And this is the kind of organization NASA has given us to organize the project. There, as you can see, there are a lot of systems and subsystems. Each system has to have a professor leader and a student leader, because this project was made fully with students and professors from UPAEP. As you can see, there are 11 systems and a lot of subsystems. For instance, the project management system, the systems engineering system is very important because it's all the technical issues in the project. Safety about the security once in the International Space Station and also in the rocket. In this case, Falcon 9 from Spacex. So you can see a lot of systems and subsystems. Next, please. As I told you, there were a lot of students and professors involved in the project. We had 41 undergraduate students, 1 master student, and 3 PhD students, but also 13 professors, 7 with a master degree and 6 with a PhD degree. Another way to see it is about gender: 19 female and 39 male. These are very good numbers. It was such we were very happy to have 19 women in this project. About the student and faculty ratio, we had 45 students and 13 professors, as I mentioned before, but not only from engineering programs. We also had business students, law students, marketing students, and even cinema students, because we are doing a documentary about the project. Next. This is the milestones of the project. We had 6 evaluations from NASA in order to be sure that everything was okay. So we had, for instance, the preliminary design review. This is only for the whole idea in the designing process. After that, we had the critical design review. This is a very, very hard examination, but even I have to mention that we had to make another examination after this critical design review called Delta critical design review, because we had to redesign some issues in the satellite. And also we had a system integration review, a flight readiness review, a lot of reviews and a lot of tension, a lot of stress, but fortunately we did it okay every time. Next, please. This is the part of the team. As you can see, a lot of people, professors and students. And I'm going to tell you about the objectives of the next, please. objectives of the project. I'm gonna mention them in step by step. The first objective was to have a flight-ready, a ready flight CubeSat for deployment from the International Space Station. So let me show you how we did it. Next, we began with high altitude balloons, making tests in order to check our telemetry, our equipment, our concepts, our ideas about sending and receiving information from the space. This is next a beautiful photograph taken in that high altitude balloon. You can see the Earth, the dark space, and you can see just the very moment when the balloon was exploding. We send the command to explode in order to recover all the equipment from the balloon. Next, please. This is another photograph we took with the balloon. You can see this is our volcano Popocatépetl. It means a smoking mountain. You can see even the smoke in the crater. So this was what we did before designing the satellite. And this is a student just showing in one of the examinations what we were designing or studying about, in this case, for thermal analysis of the satellite. And this next, this is how we have to work. This is not because of the pandemic. This is because special equipment, spatial equipment or parts have to be treated with a lot of care as an hospital. Next, please. This is the actual satellite, because we had to make some tests about integrating and disassembling the satellite a lot of times in order to have a manual to make the final integration in the United States, in NASA, before launching the satellite. After that, we had to send the satellite to United States because it was going to be launched in Florida. But before that, we had to test everything in the satellite. I'm going to show you some photographs about that. This is a special photograph because we had to ask for permission to the security of the airport in Mexico City and even to the airline in order to carry the satellite, but we asked not to pass under X-rays because they can affect the performance of the satellite. So we had to ask for a lot of permissions and kind of James Bond movie. Then we arrived to Ames Research Center in California. As you know, NASA has a lot of research centers and facilities in the United States. This is one of them. Very, very important research center from NASA, and that is the place where we made the tests. This is the lab. Next, please. I am in the engineering evaluation laboratory. Yeah. This is just the lab. We were doing our tests. Next, this is the schedule for the tests. You can see Aztechsat-1, Vive. Vive is the vibration test, vacuum test, centrifuge test, etc. Before testing the satellite, we had to integrate everything and check with the computer everything was okay. And after that, next, you can see how the satellite is connected to the computer in order to check that everything is nominal. And the next is the moment when we put our satellite in a special machine that is a very high intensity vibration machine, and we had to check. Next, you can see that I am wearing something to protect the ears, because the noise is really deafening noise. And next, this is the point where we are looking the results of the vibration test. Next is the chart. You can see a lot of intensity, a lot of different frequencies, in order to be sure that the satellite was going to resist the launching moment and in the rocket. After that, we had to check that everything was okay. So we go next. We go to the parking in NASA, just to have a window to communicate with the satellites, global star satellites, in order to check that the satellite was functioning okay. After that, we had to put the satellites in a centrifuge machine in order to simulate a launching 3G accelerations. But in these machines, we had 13G accelerations, much over that than needed in the launching, but just to be sure that everything was going to be okay. After that, we go again to the parking to check everything. Next, after centrifuge evaluation, we had to put the satellite in a special oven. Because it is possible to have a vacuum system there, and also to change the temperature between minus 15 Celsius to 60 Celsius in a very fast way. And this is because we have to simulate what is passing in the orbit. I mean, we have this kind of satellites have a revolution around the Earth each 90 minutes. So it has a 45 day and a 45 minutes night. So the temperatures are changing very fast. So we have to simulate that performance in the oven. Next. You can see the satellite connected to a lot of wires in order to check temperatures in different points of the satellite, and also to evaluate some information we need to know while the satellite is inside the oven. Next, this is the oven. Once it is closed, please do not open. And next, you can see the information in the chart, how about the temperature was moving from 25 Celsius to minus 15 to 60, and so on. After that, we had to go to the parking in order to check, and we were very happy because the satellite was okay after all that really hard tests. And this is a letter I received from NASA telling me that our satellite was ready to fly. So we had got our first objective. Remember, the first objective was to have a ready to fly satellite. The second objective, okay, this is the moment where, because the last evaluation was made in NASA in California, and this is a meeting where the general director of that center, Eugene was very happy to know that we have passed the tests. The second objective was to demonstrate that the communication between our satellite and the global star network was possible. So let me show you what we did. First of all, we had to go to the Cape Canaveral facility in Florida in order to watch the launch of the satellite. Next is myself just in front of the Falcon 9 one day before the launching. It's really very exciting moment for all of us. Next. This is the Mexican Space Agency communicating that the launching is going to be possible to see it in YouTube and etc. But we had a little problem because we had windy conditions on December the 4th, so they changed the launching date to the next day. I mean December the 5th. This is the logo of the CRS-19. This is the mission, the 19 mission for Falcon 9 and the Dragon capsule in order to send equipment to the International Space Station. We were in that cargo. Next. Oops. Next, I'm gonna show you a video what was happening before the launching.
I'd like to know more about you and your involvement with this project, as well as the rest of the students that were involved.
Okay, so I'm a student of aerospace engineering at UPAEP. Undergraduate, yes. So I'm 21 years old, and for me to be participating in such a huge project was like only in my dreams. So it's actually like a great opportunity because it's also a new career in Mexico. So having being the first generation of students of aerospace engineering and having already built a satellite, it's like incredible. So it's like an inspiration for younger people who are pursuing STEM areas, and it's also like putting Mexico in a good place for the aerospace industry.
Thanks for the question. Rosa, you want to tell them a little bit about your responsibilities?
Yeah, sure.
What did you do in the project?
So I was the student leader for the mechanics and structure subsystem. So we basically prepared the satellite for the tests that he already mentioned, and we also created an assembly manual. So this has great value because when we have, hopefully we have secondary missions, then we already have a manual, so it makes the process completely easier and faster. So we also have the experience of a satellite, so it will be easier to work with one in the future.
Thanks. Anybody else have a question?
How great has it been to apply the knowledge you're learning in school to something like a CubeSat satellite, to not have to wait to the next job, to actually jump into it and actually use what you've learned?
Sure. So right now I'm actually taking my first class in satellite technology. So it's like a great advantage because I know basically everything they're teaching me. So I'm the A+ student, so it's great. And of course you always learn better by practice instead of just like studying. So it's a great advantage, and I'm really excited to have it.
That's 15 seconds. 10, 9, 8,
7, 6, 5, 4, 3, 2, 1, 0. Engines ignition. Liftoff of the Falcon 9 and Cargo Dragon, transporting critical research to enable living and working in Earth orbit and in deep space.
Vehicle supersonic. Vehicle has reached maximum aerodynamic pressure.
A couple big calls there. Again, all normal, all nominal, and progressing as expected, flying through the densest part of the atmosphere.
Recovery AOS.
Pues nada, jóvenes, por fin se nos hizo. Ha volado el Falcon 9. Ya está en unos pocos minutos por llegar a la Estación Espacial Internacional. ¿Qué tal? ¿Qué se siente? Yo estoy hiper emocionado. No puedo evitarlo. La verdad es que es un momento que esperé muchos años. Muchas gracias a todos por su apoyo. Duro UPAEP, vienen cosas mejores. ¿Qué opinas, Rosa? Dinos algo.
No, pues fue algo increíble de ver. La verdad nos sentimos muy afortunados. Estamos muy felices. Pues qué bueno que tuvo tanto éxito. Vamos por más cosas. Muchas gracias.
¿Y tú, Ana Belén? ¿Qué?
No, pues estuvo muy padre y qué orgullo que México haya llegado tan alto. ¡Venga, México!
And there it is, successful deployment of the Dragon spacecraft. There is a view inside the unpressurized section of Dragon's trunk. With Dragon deployed, the next major milestone will be deployment of the solar arrays as Dragon makes its way to the international.
And we're still standing by. You'll see that arm start to move in the next couple of minutes. Dragon continuing to just fly in formation with the station just about 11 meters away. And you can see the arm starting to be in motion, coming alive there. In Expedition 61, Commander Luca Parmitano, the Italian astronaut, is at the controls as the prime for today's capture operation. And we just heard the call here in Mission Control Houston. The snares have retracted and capture is complete. So that call coming at 4:05 a.m. Central Time, 5:05 a.m. Eastern.
Capsule complete. Go for post-capture direction. And I would like to congratulate all of the people in Houston and around the world who contributed to the launch, navigation, and capture of Dragon. They must know that whenever we welcome a new vehicle on board, we take on board also a little bit of the soul of everybody that contributed to the project. So, welcome on board.
You're jumping right in at the perfect time as Dragon right now is situated right at the hatchway, at the common berthing mechanism on the Earth-facing side of the Harmony module. Since it was captured at 4:05 a.m. Central Time, 5:05 a.m. Eastern Time, robotics flight controllers have maneuvered Dragon using that Canadarm to its position where it now sits. And this is Mission Control Houston, those A-bolts continuing to drive. So you're looking at Dragon, it's in place at the common berthing mechanism on the bottom of Node 2, the Harmony module. And right now those 16 bolts are driving to firmly fix Dragon in place where it's going to remain for the next month.
Okay, I hope you enjoyed the video. And this is NASA congratulating us, because of the launching of the satellite. Next, this is what newspaper in Mexico was telling about us. The next is about just announcing that the deployment of the satellite. This was the deployment of the satellite was 2 months after the arrival to the International Space Station because of the schedule of NASA. But after 2 months, we deployed the satellite. Next. Better to say that they deployed the satellite on February 19 this year, and this is next. This is a actual photograph from the International Space Station showing how our satellite was deployed. And the next is a very good photograph from the International Space Station about our satellite just flying alone in the space. Just an hour after the deployment, we had the confirmation that the satellite was connecting to the global star constellation. So after 1 hour, we could say that the mission was successful. But we had a lot of things to do later. But the very exciting moment was when we know that we had communication with the global star constellation. So the second objective was achieved very fast. Finally, the third objective was to demonstrate that we could have communication to a ground station on Earth, or to several ground stations on Earth. And the next, after also 1 or 2 hours, we received information from Mexico, Uruguay, Italy, Japan, Germany, that they were connecting with our satellite. The next is a very important video for us, because it's the main guy in NASA, the general director of NASA, congratulating us about our mission. Please put the video.
Congratulate the Mexican Space Agency on the success of Aztechsat-1, which is a CubeSat that launched yesterday from the International Space Station. I also want to congratulate the university that helped put it together, UPAEP there in Mexico. This is a great collaboration between NASA and Mexico, and it's a great collaboration between our agencies. So congratulations, and I look forward to more work together.
Excellent. Thank you. Thank you, Jim.
Absolutely.
Thank you. Okay.
As you suppose, we were very happy to receive such a congratulation from the NASA General Director. After that, we had a lot of movement in the media, in shows in Mexico, in TV shows. So you can see a lot of photographs about TV shows in Mexico. And after that, we also had the honor to cancel a post stamp with the Minister of Communications in Mexico. And next, this is the stamp commemorating the satellite in this International Space Station. And that's all I would like to share you. I know there are a lot of things that I didn't mention, but this is only overview of our project. And the main point is how students and professors were involved to develop and to demonstrate what we wanted to do from a NASA mission given to us. So thank you very much, and I hope you enjoy the talk.
Thank you very much, Eugenio. We are very glad to have you here, and it was a great conference. I know it was a very complex project, and you achieved it with a lot of time that you spent here and all the team. So I will start telling you that you have a lot of greetings from a lot of countries. Latin American countries are telling you like they are very proud of you, and all the team that work for Aztechsat-1. Now I'm going to read the questions. If you have any problem here, just tell me, please. Let's start. The first question is from Mr. Haluk, he asked, why were the project team members wearing hazmat suits during the experiments?
Again, please, again.
Why were the project team members wearing hazmat suits during the experiments?
No, I didn't get.
Why were the project team members wearing special suits during the experiments?
Why? Special. Okay. Yeah. It's the audio is not too good. Because it is important not to contaminate, not to avoid dust or germs or grease or water in the satellite, in the components and in the parts of the satellite. So it was necessary. It is necessary by it's a standard way to proceed in NASA protocols to protect the satellite and the components against everything, germs, dust, water, everything. So that's why we needed to wear that suits.
Okay, so they, Mr. Haluk asked also if they were exposed to radioactive substances used in the project.
No way. No. Even we had to avoid to pass to under X-rays the satellite when moving from Mexico City to California. That's why we ask permissions. No radioactive components in the project.
Excellent. Thank you very much. The second question is, why to develop a satellite? How was the first idea to start this project?
Yeah, we in Mexico is a huge country, and we have a lot of opportunities in order to have a aerospace industry. So we at UPAEP decided to create aerospace engineering program. That was the beginning. After that, we decided to build, to design, to send a satellite to the space in order to demonstrate that we have people trained to do that. So it is very important because we are trying to develop the aerospace industry in Mexico, and also because we have to train very, very good people in this area in order to supply, in order to give to the industry this kind of the people well trained.
Thank you very much. Kailin from Indonesia is asking, when you said the satellite will be affected in a bad way by the X-rays, what was the affection?
Yeah, because the electronic components are very sensitive to changes, and they are not designed to resist this kind of radiation. They are designed to resist cosmic radiation, but not X-ray radiation. So this is only a matter of the designing of the components of the satellite, because the difference between a component used in the Earth, just in the surface of the Earth, is almost the same, but the material and the components are well protected against radiation and ultraviolet light and temperature changes. But it's almost the same. You only have to protect them from cosmic rays.
Okay, thank you very much, Eugenio. The next is from Hakim. Hakim asks, well, he's not asking really. He says, so the purpose of the nanosatellite is actually to collect info from other satellites and then send them back to Earth?
No, actually, the idea was to, I'm going to tell it again. Now the nanosatellites satellites have to send information to Earth, to the planet, to the Earth, through ground stations settled in several parts of the world. So it is very expensive to do that. So this project was designed to demonstrate that it is possible not only to send information to the Earth, but also to another satellites in the space, just to in that way, this constellation, these commercial satellites, can send information to Earth. So the point is to have even to have no ground stations in order to get information from the space. So, for instance, if I have a photograph, I take a photograph from the space in a nanosatellite, I have to send information through a ground station, but I have to wait until the satellite is in the horizon in order to have the information. But it lasts only 4 minutes because the satellite is moving so fast, 27,000 kilometers per hour. So you only can see the satellite for 4 minutes. So you need a lot of ground stations. This project demonstrated that you don't have to do that. You can send information, in this example, the photograph, to another satellite, commercial satellite, and then they send information to Earth. So you can save a lot of money using this protocol developed by us.
Hakim is also asking, I think it's related to this, is for how long can this nanosatellite stay in the outer space?
Yeah, it was deployed, as I mentioned it, on February 19th, and we think, because of our calculations, that it is going to be in space about April, May next year. This is regular way of performance, 1 year and maybe 13 months or something like that.
Okay, thank you very much, Eugenio. Now we have two special questions to support all the YCC participants this November 10. The first one is, do we still have a future in the space?
I think we have future in the space. As you can see now, we are using a lot of things that were developed in the past, and because of that, now we are using GPS. We are using a lot of information about the materials, about electronics. So we have to build the future. So yes, there is a lot of future in the space.
And the last question is, these projects will, how will these projects help us to cope with the current situation we have?
You mean the pandemic?
Yeah.
Yeah. One of the problems of the pandemic is the information. We have to know almost in real time, at the very moment things are happening, what to do. So communication is a sign of this type of the world, and space work. This kind of work in the space is just to improve communications. So maybe this is not a direct contribution, but it is in communication issues.
Thank you very much, Eugenio. And the last one I have received, it's from Jimena Gomez. She's asking, I imagine that this satellite travels at a really great speed. Does that affect the nanosatellite? And how do you test that on Earth?
Yeah, we have a mission operation facility at UPAEP, and we are following the satellite every moment. So we have information from our ground station, but also from Global Star, but also from other ground stations in the world. So we know exactly where is our satellite every moment. And yes, the speed of the satellite is, as I mentioned it, 27,000 kilometers per hour. That is the speed of the satellite. But it is moving, as you know, from your physics lessons, that this is a kind of inertial movement. So no forces are acting in the satellite. So it's just like it is quiet. So no problem.
Oh my God, you know, a lot of questions are popping now. I swear it's the last one, Eugenio. We are almost ending this conference. So it says, how much did the nanosatellite cost? It's from Hakim.
Yeah, it was a project about $500,000, but also counting the launching, the tests, the materials, the traveling because of the examinations, everything, more or less $500,000.
Excellent. Thank you very much, Eugenio. And please receive all the greetings from Argentina, Mexico, Paraguay, Chile, Colombia, Costa Rica, Czech Republic, Indonesia, United Arab Emirates, Kuwait, United Kingdom, Spain, France, and Kazakhstan, please. Palestine too. We want to thank you very much. Now I am going to hand the mic to Ms. Vera Suarez. Thank you, Eugenio. It's really nice to see you.
Thank you very much.
Well, it has been a really amazing conference. I'm pretty sure that all people that having this transmission online and hear all the information that you have shared with us, Mr. Eugenio, have been excited and has been motivated to participate more in things related on space. Also, it's very good to understand that things related on space have a future, and it's really important to focus also on how the things here in Earth could be improved by the things that you are doing with the space. And well, congratulations to you, to your team, to the UPAEP that is focusing on support this kind of activities and this kind of projects to improve the goodness of all of us. And it's also so important to highlight this commitment for involve the students and the teachers with something physical to do, and not only with a theoretical information that they receive. So thanks so much on behalf of MILSET. We are so happy to have you here and receive our deepest congratulations and our deepest gratitude for your presence here. So I come back the micro to my colleague Liz.
Thank you.
Thank you very much, Bere. And one more time, thank you, Eugenio, and all the people that are watching this broadcast. I hope you really enjoyed. I am sure you did. And for the next conference, we will present the next conference on October 16th with the name, The Impact of New Media and Transculturation Among Young People Across the Wide World. Please follow us on social media to get more information about the speakers, about all the dates scheduled for these conferences. And don't forget, if you are between 13 to 25 years old, you still have time to register to the MILSET World Virtual Young Citizens Conferences debate tables that will take place on November 10 to 15, and the registration deadline is on October 15, so you still have time. We really want to hear your voice. We want to know, what do you think about the situation we are living right now, and how can we invent a new world? And we also invite you to participate in all MILSET programs like the MILSET Science Photo Contest, which is a program for amateur photographers. And it's really an easy deal to get a good shot and participate. And thank you very much, everybody. See you in the next conference. Goodbye.
Bye-bye.